So we are going to evaluate this definite integral by using the method of trigonometric substitution. Now in here we have to make a substitution keeping this quantity in mind. Now if it was a square root of 4 minus x squared, we would have gone for x equals 2 sine theta. But in this case, if you recall the Pythagorean identities, then you remember this, that 1 plus tangent square theta equals secant square theta, right? So if we have this, that is, and this gives us, what does it give us? This gives us that tangent square theta is secant square theta minus 1. So if we can bring in this quantity in here, then the square root sign will disappear. All right. So for x square minus 4, to get a factor of secant square minus 1, what we may do is that we may take x equals 2 secant theta. So 4 will factor out, and this will be our other factor. So what we are going to do is that we shall write 2 secant theta in place of x. Okay, so we have 2 secant theta. So this is going to become 4 secant square theta minus 4. Okay, and that will be, as we said just a moment ago, that this will bring this in as a factor, and which is going to give us 4 tangent square theta. All right, so this, and then with this, when we apply square root, our square root signs will disappear. Now notice this here, that we are taking x equals 2 secant theta. So when x is 2 square root of 2 as the lower limit over here, what we get is 2 square root of 2 equals 2 secant theta. That means secant theta is square root of 2. All right, and what that gives us is that gives us that for when x is 2 square root of 2, theta is how much? Theta is pi over 4. Okay, and when we go to the upper limit, what do we get? Here we have x equals 4. Okay, so x is 4 here, so that gives us that 4 equals 4 equals 2 secant theta. All right, that means secant theta is 2, which means, like cosine theta is 1/2, or so that gives us what? Our theta there is pi over 3. So in this territory, tangent is positive. So what we shall get for square root of x square minus 4 is that we will simply get square root of 4 tangent square theta that we found here. And since tangent is positive in here, this will just turn out to be 2 tangent theta. Okay. So now with all these substitutions, our integral changes to pi over 4 to pi over 3. All right. Okay. And by the way, if x is 2 secant theta, then dx would be 2 secant theta tangent theta d theta, because the derivative of secant theta is secant theta tangent theta. So here for dx we get 2 secant theta tangent theta, and here for x square we will get what? We will get 2 secant theta square, right? And then here we have simply 2 tangent theta. All right, so if we simplify this all, okay, let's try to simplify so that we are able to integrate. Okay, then in that case, first of all, this 2 square is going to become 4, and by the way, this is misplaced here. This is secant square theta here, right? And let's just change it a little. It becomes times 2 tangent theta, and also let's place this here. Okay, so and now what will happen? Tangent thetas will cancel, these 2's will cancel, and secant theta will reduce this secant square theta to secant theta in the numerator, in the denominator. Okay, so what happens? First of all, we have 2's cancel, right? And then this thing, tangent thetas cancel here. Okay, and then we have only 1 secant theta left here. Okay, so that becomes what that will become? 1 over 4. Okay, the integral from pi over 4 to pi over 3, that of cosine theta. All right, and who is the antiderivative of cosine theta? That's sine theta. So our answer will be, we are almost there. Okay, so our answer would be here the antiderivative is sine theta, the upper limit is pi over 3, and the lower limit is pi over 4. So we get 1/4, right? And sine of pi over 3 is how much? Square root of 3 over 2. All right, and sine of pi over 4 is square root of 2 over 2, right? Okay, so that's our final answer then. Okay, and we can just check it if you would like, and the answer here is, yes, answer is what we got. All right, so let me know if you have questions.